Hi guys and welcome back. Um, Today we're going to be looking at electronic configurations. This is something you've kind of already seen in previous examples, but here today we're going to be addressing that, looking at what these orbitals are, how they're filled and how they relate to reactions in chemistry as a whole. First off, as we said before, you've got the nucleus of the atom that's got protons and neutrons in it. Yeah, we know this you're thinking, but just to have a quick refresher there. And we also said we got electrons orbiting around that nucleus. So a few things about the orbits. First and foremost, these orbits are precise. They're precise amounts of energy. So you're not going to find an electron randomly orbiting the nucleus of an atom. They are sitting in shells or orbits. They're called. You've been introduced to them as orbits. We also call them shells, just for the purposes of this tutorial. So the terms are kind of interchangeable. But each shell, and we discussed three of them here, occupies a specific energy around the nucleus of the atom. And that part there is true at A levels. So keep that one in mind. So there's no randomness here. You're not going to find an electron halfway between a shell and another. They're going to occupy specific shells. That's something we need to understand here. Kind of pretty much said all that here in terms of the words, but I will leave that there. And we do repeat this further down in a more diagrammatic format, which is what we have here. So we're going to be discussing the atom aluminium here in this case. Another thing I'll say here is the nucleus now is not so important to us. So I'm not going to be too pedantic about making sure that I've got the precise number of protons and neutrons, aka blue and green spots in there, because they're not relevant as much. We're talking about the electrons, which all have converted from being little circles to now crosses. I've done that now because that's how they're represented in the books. So I'm going to keep with convention there. So the first thing you'll see, if you can think of the previous tutorials we've done, is you've got the nucleus and you've got the first little circle or shell one, as we call it, on the outside of the. I don't know if I've got shell one still filling there. My apologies. That should be shell three still finishing there. So please excuse that. I'm probably going to have to somehow edit that. But what you've got in here is shell number one, which is full. It isn't still filling. It is full. That shell can take a maximum of 2 electrons. And the only place where you might see that's half empty would be when you're looking at the nucleus of hydrogen that we saw earlier on. So hydrogen is filling up the outer shell, or trying to, sort out the stability of its inner shell there, shell number one. And of course, then you've got helium, which would have 2 electrons in its outer shell there, which would be for helium, that would therefore be full. So once we've finished with helium, that is the inner shell one now full. So now we have to move out to another shell. This is shell number two now. So electrons will then start populating that shell, and it can take a maximum of 8. So you'd start off with 1, 2, 3, 4. Then you begin pairing them up until you've got the maximum of 8 electrons in that shell. And then you go on to shell number 3, which is higher energy still. So what you have here with aluminium is we've got the with 3 electrons left over. So you go 1, 2, and then 3 for filling it up. So you've got the 1 electron up there, 2, and then 3. That's how you would fill it up. 4 would go over there, and you start pairing them up. So that is essentially the electronic configuration of aluminium, how electronic configuration works. So from that, we can say that the electronic configuration of aluminium is 2, 8, and 3. That is the electronic configuration of aluminium. But generally the rule, so we can apply it to other circumstances, other elements, not just aluminium, here they are to help. So electrons will fill the lowest energy shell, shell 1 first. That's precisely right. It'll always be the lowest energies, shells that will be filled up first, and then it will go out as required. Each subsequent shell increases with energy, so there's more energy for each shell as the electrons go up to it. And the first shell, as we said, holds 2 electrons. The second shell holds 8 electrons. And the final third shell holds 8 more electrons. So 2, 8, 8 is the main sort of electronic configuration you need to be aware of here. And that is how we are going to be expressing electronic configuration in atoms. Why is this important? Well, because electrons are a bit like money in the material world of atoms. They're always getting exchanged, or they've been given away in return for causing an alliance between one atom and another to form a compound, which is where you get one atom bonding with another one. So that's why electron transfer is important, because one of the biggest things that takes place in chemistry, of course, is how one element reacts with another element. They could form a compound like H2O, for example, carbon dioxide. These are all compounds that are formed from marrying up, for want of a better word, um, hydrogen and oxygen to form water, carbon and oxygen to form carbon dioxide or monoxides. Um, these are all compounds, and it's all kind of born out of this, and the desire for oxygen and carbon and hydrogen to be stable. Because we'll get to that in a minute, but um, how the electronic configuration ends up will determine how reactive that element is in the end, which is something else we're going to come to, but not for a discussion here. All I want for you to take away from this for now is the 288, how we're filling up shell number 1, shell number 2, and shell number 3. That's all I want you to take from this tutorial. In the next one, we'll be talking about how we actually fill these, and to give you some idea there, and have to give you a rounded knowledge before we start looking at bonding, different types of bonding, and ultimately the periodic table. We'll have to probably mix them when we get to the periodic table. But that's where we are. So I'll see you back shortly when we talk about filling shells. See you then.